Our twin islands of Trinidad and Tobago has a population of 1.39 million people. It is estimated that each household has at least one vehicle. The lack of reliability, safety, and effectiveness of our public transport system has created a blemished image that has motivated citizens to purchase a personal vehicle as soon as they can afford one. The continuously growing number of cars, paired with the fact that our country's largest working class, the middle class, traverse the highways every day to get to work at our various economic activity hotspots, such as our capital, Port of Spain, our industrial estate in Planisas, and many other destinations, has caused traffic pileups throughout our major road network.
There's been an increase in sales in the automotive industry over recent years. This increase has had a domino effect on the traffic congestion in the nation. Traffic congestion has been reported to be one of the highest obstacles to productivity. In 2014 study by Central Bank of Trinidad and Tobago, 54% of persons has indicated a 10% decrease in productivity due to this. Long hours spent in traffic results in fatigue, irritation, and sometimes bad driving can occur. This lethargy in the early morning prevents people from operating at optimal levels, thus decreasing the overall productivity.
This time study was conducted in the months of March and February for 1 week each between Monday to Friday, using an app called Trip Logbook that utilized the power of GPS. The time spent in the traffic and the distance traveled in it was recorded. 4 readings were taken each day in 30-minute intervals between the hours of 6 a.m. and 8 a.m. A starting point was determined for when to start collecting data, which was the point where the merging zone to get onto the ramp of the flyover. This would only apply if no traffic was met before this point. If so, then the app would be started when merging onto the tail end of the traffic and coming within 1 meter of the vehicle in front. Data collection was stopped on entering the campus gates and then recorded. A reset route was also made to allow for hassle-free successful recordings. This was done by passing by the Brian Lara Stadium and merging back onto the highway via the Gasparilla Bypass Road. 1 car was used when collecting data, with 1 person in the passenger seat operating the app and the driver focusing on the road. Qualitative data such as observational data was also noted.
We can best show the 4 30-minute segments were recorded between the 6 to 8 a.m. period each week by using multi-series bar graphs. The traffic congestion increased significantly from 7 to 8 a.m. as can be seen by the tall blue and yellow bars on the graph. For this month of February, the congestion caused a maximum travel time of about 16 minutes just to arrive on campus. Looking at the March data, we see a similar trend. There is, however, an anomaly where congestion decreases from the middle of the week. What we can assume for this anomaly is a productivity drop midweek where persons arrive to work after 8 a.m. or simply that work hours in the San Fernando area peak during the weekends and all the way to Monday and Tuesday, given the nature of many businesses in this area being in entertainment, food, luxury, and commercial item sales. The weekends are the times that people mostly have off, and Mondays and Tuesdays are known days for specials being offered at some of the entertainment and food venues in the area. From our measurements and observations, we have determined that the traffic congestion at the Tarouba flyover is to be blamed by the major bottleneck at the western side of the overpass. Dealing with this major bottleneck, therefore, is key to solving the congestion problem.
There are 3 alternative solutions that would help the flow of traffic if implemented, and each one with its own pros and cons. The first being installing a dynamic traffic light system. As you can see in the representation, they are dynamic traffic lights that project in 4 directions that are placed in the main bottleneck region, and they would change in accordance to the amount of traffic in each lane using sensors and algorithms, thus regulating the flow of traffic in a timely manner. This solution can be implemented in a short period of time and would not require a heavy investment. The only drawback would be that of regular traffic lights can malfunction periodically. The second being replacing the existing traffic lights at the junction on the Tarouba Link Road with a roundabout as shown. This would work if there is a blockage of right turns to those heading west onto the highway, as depicted by the light blue arrow. By having those vehicles travel further west and use a roundabout to travel back to east would result in continuous flow and less waiting times. The only drawbacks, besides the estimated price being $32 million, would be the interruption of traffic flow during construction and impatient drivers not wanting to travel the extra distance. Lastly, the La Gauche design, with La Gauche meaning left in French. In this design, all traffic flow lines turn left. As depicted in the graphic, there is no crossings of traffic flows from both directions, and it is solely up to the drivers doing safe merging or taking their respective or desired routes. The overpass is doubled in size to accommodate more vehicles, as the drivers would also be merging on the overpass. The drawback of this design is that it is the most expensive solution that can be implemented and estimate up to $300 million and can take years to complete. It would also interrupt the current flow of traffic during construction and would require excess amounts of land for northern parts of the design, as some houses would have to be relocated. These are all effective solutions that can be used to solve the problem.
When coming up with a solution to a traffic congestion problem, a lot of factors are taken into account. For our congestion problem at the Tarouba flyover, our best recommended solution is a smart traffic light system. Reasons for this are the lower cost. In this case, it will take less than $100,000 to $200,000 to implement, as well as the fact that it can be implemented quickly with minimal disruption to traffic flow, as the smart traffic lights would be mounted to the sides of the intersection and no modifications to the road itself will be required.